Hi, I'm Annie.
And I'm Io.
Hey builders, stop typing and start interacting. We're moving beyond the text box. The future isn't just about chatting with AI, it's about immersive real-time experience. And to celebrate the power of multimodal AI that can help you see, hear, speak, and more.
Let's build the future of agents!
Hi everyone!
Hey!
Welcome to this new episode of Hands-on AI, where we walk you through step-by-step on some AI labs. I'm Annie.
I'm Io.
And today we're gonna explain a multi-agent lab. So by the end of today's lab, you can learn everything from MCP server to ADK agents, all the way to agent-to-agent protocol. Are you excited, Io?
I'm super excited. That sounds so really fun. But before we get started, it's also important for those of you who want to follow along with us, make sure that you have a few things set up in your environment. So we always recommend using a laptop or desktop.
Don't use your phone for today's lab.
Exactly. And two, make sure that you're using a personal Gmail account. I know a few of you like to use a corporate or educational account. Sometimes those come with restrictions. So we always recommend using a personal Gmail. And that said, outside of that, Annie's going to now walk you through a few billing enablement steps, just so you can link. You can redeem credits free for the lab and link them to your project.
Yeah, also I forgot to mention, this is a two-part series. And today, I'm going to lead you for the first part. Tomorrow, I'm going to lead you for the second part. And by the end of this two-part series, we're going to have a boss fight because this is RPG games thing. Are you ready for the boss fight, Io?
I'm super ready. Yeah, let's go.
Yeah. Okay, so before we claim the credits, you probably have seen the link on the screen or in the chat about the link for today's credits. And let me walk you through how to claim that credit. So this is the link. You may see a different title over here, but essentially this is just to help you will see this button. Click here to access your credits and making sure you sign in with your personal Gmail account. Okay, I'm clicking this button. You will see that it's opening a new window and I ask you to redeem, claim this credit. And just making sure every information is correct and accept and continue. Okay, so you will see credit successfully applied. That means you have successfully claimed your credits. For those of you, some of your screen may show up like a payment method requirement, but you did not need to input any personal payment information. If you saw that window, just close that window. Don't worry about it. And let's get started.
I'm super excited. Okay, so it looks like we're going to be diving into steps 1 through 5 of the lab, as Annie mentioned. And then for tomorrow, we'll cover steps 6 through 10, which involves A2A, building callbacks with the ADK system. But let's first learn what is MCP, and Annie's going to walk us through the overall architecture, and then we'll do a deep dive.
Yeah, thanks, Io. And you can take a look at this high-level architecture picture, and this is the multi-agent system we're going to build. And you can take a look at this. You can look at this diagram from bottom to top. And the bottom layer is tooling layer, which is Io mentioned we have different type of MCP server we're gonna build today. We're gonna build custom MCP with API or general function. We're also gonna use, what is it, Io? What is the type of MCP server? Another type?
MCP server through Toolbox.
Toolbox.
It's a really good way of connecting with databases. It provides you all the configuration code that you need. So we're going to learn 2 different ways as part of this lab. Again, as MCP mentioned, connecting with MCP servers through external APIs, but also through Data Toolbox. And also there's another new way called MCP managed servers to Google.
Google managed MCP
servers, but we'll cover that later on.
Yeah, all right. So this is a tooling layer. And once we build a tool, we need to connect the tool to our agent. So the second layer is domain workflow. We're going to cover how to build ADK agent, more specifically workflow agent. So we're going to cover different type of workflow, that is sequential ADK agent, parallel ADK agent, and loop ADK agent. So once we connect the tool to our ADK agent, we have different specialized agent ready. Right? So the last step is at the very top, we have this orchestrator agent, the root agent. This is agent standard. We want to orchestrate everything together. So this is through our agent-to-agent protocol, right, Io?
Exactly. So agent-to-agent protocol, which we'll cover later on as part of day 2. Tomorrow is a really good way of connecting agents with remote agents, going organizational boundaries. So if you have within intra-boundary organizational boundaries, local agents makes a lot of sense, but oftentimes you need agents to communicate with other agents across boundaries.
Yeah.
So
exactly.
Yeah.
Yeah. So if you're curious about A2A, you have to come back for tomorrow's episode. And you can also see that on this diagram, we have like state and memory, right? So we're going to also touch a little bit about ADK agent, memory, and state. And we also have ADK plugin here. If you're curious what it is, you have to come back for tomorrow.
Yep.
Right? Okay. All right. So let's get started for today's part. And because I already claimed the credit, so what I need to do now is I'm going to step 3. On this page on the left, step 3 is drawing the summoning circle, and you just basically go through everything following the instruction over here. And as you can see, the very first step is we need to activate Cloud Shell on Google Cloud Console. So that means we need to first open the Google Cloud Console, and basically I just type Google Cloud Console. And then I'm going to Google Cloud Console, click this. Or you can just simply go to console.cloud.google.com, right? So on the top right, there's a button called Activate Cloud Shell. So I'm clicking this button, and I'm going to open Cloud Shell environment. And this is where you're going to coding for today. This is basically like VS Code on cloud, right, IO?
Exactly, yes.
Okay.
Yeah, and one thing to keep in mind is, as Annie mentioned, it is kind of like VS Code for cloud, so it is persistent files. So this Cloud Shell is essentially a remote VM, so you can come back to it. So whatever files that you create today as part of the lab, you can start and stop if you want to. Come back 2 days later, the files will still be there.
All right, so you can see that we have our terminal open on this Cloud Shell. This is basically the terminal. Similar to terminal for VS Code. How I usually like to navigate is I like to open this in a new window. Okay, so if you open in the new window, you can see on the top right, we have this open editor and open terminal. So I usually like to click open editor and open terminal so that we have both editor interface and terminal interface. Now I'm coming back to my instruction and ready to run more commands. So those are instructions, basically just open the editor and open the terminal. So now we have the terminal open. The first step is let's do gcloud auth list. So making sure you already authenticated. So I'm coming back to this terminal and I'm pasting the gcloud auth list to making sure, this account is authenticated. And then what's next is let's clone this project. So I'm copy this command, copy those command and go back to my terminal. And I'm going to paste it over here. So what it does is it will clone this project. Why we have 2 projects that we want to clone?
Great question. So for the agent versus architect, it comes with a lot of starter files and template configurations for essentially the multi-agent system that we're going to build. But also, again, as Annie mentioned, essentially we're going to be building up to a boss fight in the cloud where our agent that we're going to build is going to be fighting with this monster. That's also another agent. So they're going to be communicating via A2A to kind of get that dungeon environment set up. That's kind of stored in a separate GitHub repo. So essentially, you have to kind of clone that and kind of just build it ahead of time. So by the time we build our multi-agent system, we already have a dungeon environment that's already built. So that's pretty much why we're downloading 2 separate GitHub repositories.
Yeah, thanks for explaining. And next step is let's run this init script. I copy this and paste to our terminal. So you can see that once we copy this, it will create a new project for us. And right now, it will create a name start with agentverse summoner. So I'm running the agentverse summoner. So you probably see a different name here, but usually it starts with agentverse summoner. So what it does is it will create a new project for you, and then it will link the billing account you just claimed and link that billing account to this new project so that you have this new project that has a billing account attached to it. And if you successfully run this command, you can see this yellow font that is a project it's setting that is correctly set to our environment.
Yeah, and all we're pretty much doing, again, as Annie mentioned, is linking the billing account that was redeemed with the project that's been created.
Yeah, so this step is making sure you select the project you just created. So what I do is I'm coming back to this Google Cloud Console. This is console.cloud.google.com. And then on the top left, this is a project selector, right? And on the All tab, I'm selecting this project that's just created. So now I'm currently in the Google Cloud Console. I'm selecting the project. Great. And now let's come back to set the project ID if needed, and copy this, and then paste it over here. Since it's already set to this project, so I should be good to go. And next step is we need to enable some Google Cloud APIs. Let's see what the API we want to enable here. We have SQL admin, storage, API, platform, cloud build. Do you know why we need to enable those API?
Yeah, great question. So for something like AI platform, Google's APIs.com, that's essentially the underlying, APIs for Vertex. So when we're communicating with Gemini behind the scenes, essentially leveraging the Vertex API. For something like cloud storage, we may be storing assets like media files in Google Cloud Storage. Essentially, you want to make sure that your project has these APIs enabled. One question that comes up often is, when you enable APIs, are you going to start incurring cost? Just by enabling APIs does not mean you're going to have a cost in your project. Essentially, just makes sure that these services are available for use.
Great. Thanks for the explanation, Io. So while we're waiting for this command to run, API to run, maybe we can talk a little bit more about the MCP server we're building for today, right? So just to give you a quick overview of what is the MCP server, right? Because we just assume I know MCP server, just give a quick overview. That first, before we know what is MCP server, we need to understand what is tool, right? So tool, basically, agent, in order for agent to connect to the external world and do some action for you, you need to have a model as a brain and connect external world through the tooling, right? And then here we have MCP server. So you can take a look at this picture. That on the left-hand side is MCP client, it's an agent client side, and on the right-hand side is the MCP server. Basically, for agent that's connecting to the external world, you will call those MCP server through here. But why don't we?
And not to cut you off, but also when she says external world, essentially there are limitations that come inherent with these models that kind of are the brain behind these agents. So while these agents may be powered by something like Gemini, which is really powerful and really good for multi-step reasoning, it doesn't have access to real-world information. So what's a use case such as, give me the current exchange rate between the USD and the pound? That's not something I have access to, but it could leverage a tool to get that information. Also, there's use cases where you may not want an LLM to be doing math, because it's been shown that when it comes to some things like math, it may not be as good. But what you can do is have it connect with a calculator tool that's a little bit more deterministic. So there's reasons why, again, tools make sense to use in context of agents. Then Annie's now going to explain essentially how MCP kind of expands on that same, reasoning.
Yeah, so actually in today's lab, we actually have a general function that is doing the calculation. So that's a great example of building an MCP server that's doing some math calculation. Also, for Gemini, it actually grounding with Google search. So if you're using Gemini model, you do not have to, if you look for current currency, the model itself actually can do the search. But if you're using different model, it may not have that Google search capability.
It may not have a Google search tool, but there are open source third-party tools that kind of link to real-world kind of web data. So there's alternatives.
Yeah. So MCP server is like this universal adapter. So whatever tools you're connecting to, whatever like MCP tooling, and you connect to this universal adapter, so that MCP server this tool can basically connect into any type of agent, no matter it's ADK or if it's a different agent framework on different cloud, deploy on different cloud, right? So MCP server really allow you to do a complex design, and it's a standard protocol for agent to communicate with the tooling. And let me go back to this stage. So once we are successfully enable the API, and let's continue to do this create artifact repositories. Essentially, we want this so that we can eventually do the deployment. Would you mind explain what are the artifact repository here?
Yeah, so artifact repository is essentially Google Cloud's container image service for hosting. So essentially, later on in the lab, we're going to build container images for each of the agents that we kind of define in the code. And then later on, we'll deploy those agents to Cloud Run by essentially pushing those images to the Cloud Run service. We're deploying those images to the Cloud Run service. But essentially, Artifact Registry has to kind of host all those images. So we're just building our namespace for those images ahead of time.
Yeah. And if you see this command currently has nothing equal, or if you see the URL is empty, that's completely expected. So do not have to worry about it. And we can continue to do the setup permission step. So just copy okay. I guess I happen to copy this. I'm going to copy this and come back to the terminal and making sure. So right now, I am just adding those permissions so that my service account now able to have those roles to connect. So for example, I have service account now able to have these roles to manage the storage, and also have a service account to manage the to do the cloud build editor. And
and just to kind of echo that statement, in Google Cloud, almost all actions occur under an identity, whether it be a user identity or what's called a service account identity, which is essentially the identity of some sort of service. So essentially, if you want to be logging or deploying, you have to make sure that your default service account has the ability to actually write logs or to deploy. So it's just an additional step.
Yeah, it's like a robot account of yourself and trying to do all those actions on cloud.
Yeah.
Great. So next step is let's try to run this command to deploy our dungeon, because you do not have to do anything to build a dungeon. You want to first deploy them, so later on you can do the boss fight, 0A to A. And let's run this command, and we're going to have a deployment process kickoff. But this is not a black box process. Other than the command, like a log you're seeing on the terminal, you can also open Google Cloud Console. I guess we already opened it here. And I can search cloud build to see the current building process. So I search the cloud build, and I'm going to open this cloud build history. Right now, haven't kicked off. I guess I was running the, okay. So it's submitted in the background. Let's see. Let's refresh it and see. Does it start the... Okay, so it started build. I'm going to click in the build, and you can see this is a building process. And let me zoom out so you can see that it's the auto step how it is building behind the scene. So once it is finished, we will see this deploy to Cloud Run. So I'm going to search Cloud Run. And right now, we're not supposed to see anything because it's still in the deployment. It hasn't deployed yet. And we will check that but at the very end. So while we're waiting for the deployment, because it's still deploying, let's continue for our prepare script. So just copy this script and paste it to the terminal. And here we are preparing our environment, finally ready to build this multi-agent system.
Yeah.
Great. And so while we're waiting, we're going to talk about what are the tools we're going to build. What are the MCP server we're going to build? Because before we talk about why we need MCP server and what is MCP server, right? So now we're going to talk about how to build different type of MCP server. So all right, let's take a look at how to build those MCP. And here we are using our ADK to build MCP. And on the right part is how to use ADK to build MCP server that wrap the external API. And also we have this MCP server that implement a general function. That's basically what I previously mentioned, that you can do a math calculation, right? So here is an example of how to build MCP server, do the mathematical calculation. On the left, we have MCP server with database toolbox. Basically, you're building an MCP server that easily connect and fetch and query this external database. Here we have this Cloud SQL data prepared for you. And the very first MCP server we're going to build is external API type of MCP server with ADK. And let's take a look at how to use ADK to build MCP server with this external API type. So let's go back to how to do it in the code. Okay, in this code, you can see that first you need to navigate to this directory, right? So what I'm doing is I'm copy this file, and then I'm going to this editor. So right now you can see that I already have this file open. But for those of you who don't have this open, you can go to like top left, this file, open folder, and select the architect for today. Because the dungeon is the one that the boss want to fight. So you do not have to touch dungeon. You just open the architect and click OK. You will open the architect folder for you. And in the architect folder, let's look for this MCP server /API /main file. So now I'm currently at this main file. And what I need to do is I need to replace this magic core. I'm copying this and paste and copy this code to the magic core. And let's take a look at what does magic core mean. So here we are creating those two functions, and each of them are wrapping those API, right?
Yep.
And then what's next is in the same file. So say MCP servers API main file, you need to replace this one. Just search for things we want to replace, and let's copy this to the things we need to replace. Yeah. So what we do here is we have this annotator that wrapped the list tools and call tools. So here is how exactly you're using ADK to create the MCP server. But why list tool and call tool? So early on, we have this file that, when ADK is connecting to MCP server, that first it will load all the available tool. And once model decide, okay, I'm going to use this 2A or 2B, you're going to call the corresponding tool. Yeah. Right? Anything to add?
Exactly. No,
no?
That's the exact workflow. Client to server response.
Yeah. So here we are creating those two tools, and they are wrapped with different endpoint. So we basically finished this. So we finished the first type of MCP server, with external API, right? Because you just wrapped them. So those are basically Crystal, Shadow, and Moonlight Cascade, right? Did I pronounce it correctly?
Yeah, Privacy Shatter and Moonlit Cascade. Yeah.
Yeah. Thanks.
No problem. Yeah.
Okay. So next one is, let's take a look at this general function MCP server. And basically at the general function, you also go to this MCP server, but now we're at general folder. Over here, that you can see the code are pretty similar. First, you have this type of tools. How to say this? This is a game.
Leviathan search.
Okay. Leviathan search.
Yeah.
Another one is
seismic charge.
Seismic charge. Cool. So you can see that it's actually doing the mathematical calculation, right? And here is you're creating this function tools over here, and in the list tools, you're also using ADK to MCP2 tag so that you're creating this MCP2 tag. Okay, let me go back. Yeah. So you're creating this MCP server tool with general function. So now we have this tool MCP server created. Let's deploy them to Cloud Run. And so what I'm going to do is I'm going to copy this command and paste it in the terminal, not to the file, to the terminal. And let's take a look at what is the code we called. So we run this gcloud build submit, and we're using this cloud build.yaml file. Do you know what is cloud build YAML file and why we are deployed this way?
Yeah, so Cloud Build is essentially like Google Cloud's engine for CI/CD. You can use it to automate and build, various things such as services or run pipelines. So for our particular use case, we're using the Cloud Build YAML files to automate a few steps. One being the building of the container image. That's gonna.
Yeah. So here is a build container. As you can see, we built 2 container.
Yeah.
Simultaneously, because we have 2 servers we want to deploy.
Exactly. Then the next step, as we talked about earlier, artifact registry is essentially where we host and kind of store the container images. So once we build the container image, we're going to push it to the artifact registry namespace that we created earlier. Then finally, after we've done that, essentially we can then deploy that same image to Cloud Run. And then if you scroll down, you can kind of see all the parameters that we're adding to the Cloud Run deployment. So Cloud Run is essentially a serverless service for Google Cloud where you can run, micro apps and various other things, but overall it spins up and it spins down when you're not using it. So you can set things such as max instances or min instances.
Yeah. So this is the Cloud Run service over here. And that's also, again, you can also see the build process. If you search Cloud Build, you will see the process that the deployment process over here. You can see that previously we have 2 build successful, right?
Yeah.
Okay. So while we're waiting for the deployment, we can see in the Cloud Run console, we should be able to see the things that's deployed. So again, making sure when you go to the Cloud Run console, you're selecting this agent with project. And okay, am I at Cloud Run or Cloud Build? Cloud Build. Okay, let me search Cloud Run.
Yeah, so at this point, if you recall, what we've done so far is we created the dungeon ahead of time. So for right now, all you should see is pretty much the dungeon, as well as it looks like the API was able to deploy really quick as well. So
Oh, so I think the API is the one that we are we will preload this in the script. I think the tool that is still currently deployment.
Okay.
Yeah. So it looks like still deploying. And so while we're waiting for the deployment, we can go to the next tab of MCP server, which is Database Toolbox MCP server. And let's take a look at what is Database Toolbox MCP server, right? Okay, so as you can see here that we have this database in Cloud SQL. Those are all the available data, and then with the MCP server toolbox, basically you're implementing a tool to easily access or query or control connecting to that database. Like I am curious, if I'm not using database toolbox, if I simply just build a normal MCP server, how would I connecting or like query this? How would I build an MCP server that query from this?
Oh, sure. Great question. You would probably be leveraging within the logic of that custom MCP server, logic that authenticates and then kind of executes commands against whatever database, whether it be something like Cloud SQL or Cloud Spanner and so on. The nice thing about MCP toolbox, database toolbox, is that it kind of normalizes all the configuration across all these DBs. So essentially, you don't have to kind of worry about creating custom, MCP servers for each database. You can kind of connect directly with MCP Toolbox, configure it directly there, and then start interacting with different databases directly with via an agentic system. So that's the benefit. Essentially, it accelerates your development velocity.
Yeah, and MCP Toolbox is also able to connect to many different types of database. And today we just only have this example. But if you go to the doc on the screen, you can also, check how many database you can connect to. And let's take a look at how to connecting to this database toolbox, using database toolbox to connect into Cloud SQL, right? So let's first do the data setup command. I copy this and paste it to the terminal. Okay, it's still deployment. I'm gonna open a new tab. So I'm gonna paste it over here. Yeah. Basically, it will first activate the environment for me, and then go to our project, and then run the script to set up so that we can use the MCP toolbox. And then later on, so first it will making sure we have this SQL data we connecting to. So those data setup command is basically to set up this Cloud SQL with some data that we're gonna interact with, because we need to have a database so that and then we're building this tool to connecting to that database, right?
Yeah. So first create data, seed it in the database, and then interact with that data via the MCP toolbox.
Yeah, looks like it's still storing the data. Okay, great. So right now, we have this ready. We have this data instance ready. So I'm gonna copy this. I'm gonna copy this console and paste it. And making sure that, this is AgentWorks, right? As you can see, this is Cloud SQL, include Cloud Console. And in the Cloud SQL Studio, you can see log in to your database. We need to follow the instruction to log in. And here is the instruction. And in the login page, you need to first select familiar. And then you need to enter Sumner as user. So I put Sumner as user. And then this is the password. So once we authenticate, we're able to see this data in this table. Great. So we can give a try by let's copy this and open this query and then paste it. So here are all those existing, different type of file familiar name. We have this Infernal Lash. I don't know how to pronounce this.
Yeah.
You can tell I don't play many games.
Ember Storm, yeah.
Do you play?
But overall, essentially, we're building an agent that, given what we call kind of an elemental, it would know exactly what type of attack and ability to kind of, leverage to inflict the most damage. So again, this is an RPG role-playing scenario. So essentially, we've stored different types of familiar names, the abilities, the damage points, and the element that it's for directly in the database. So whenever our agent needs to know what to do, it can kind of run the MCP server tool, get this access to this information, and then leverage it as part of its delegation and response. So we're going to see that later on. But that's essentially the overall scope of what we're building. Yeah,
thanks for explaining. And before we move forward, I want to making sure. I guess you don't have to worry about other MCP server. Okay, let's take a look at how do we connect into that database. So I'm opening this MCP server toolbox. So go to the DB toolbox tools.yaml file. So also is a config file. That's okay. Sorry, I guess I'm opening the wrong file. Yeah. So this is a config file to configure what is the database we're connecting to, what are the tools I'm creating, and how to implement those tools. And let's take a look at each of them. So first, we need to replace the source with this code. This is basically to connecting the SQL we just created. As you can see that this project ID, we need to replace this project ID with a real project ID. And then to get the real project ID, I'm going to my Google Cloud Console, right? I can just copy this from the IDE. Or you can follow some, I think we have some command to get the project ID. But again, this is the easy way, right? So just go to the Google Cloud Console and then making sure grabbing the ID from here. And then, so I'm copy here and I'm going to replace your project ID placeholder with a real project ID. And what's next is we need to replace existing tools. Let's see what tools we want to create. We want to create this lookup ability to be able to look up in this, look up all the ability available and what are the damage for each ability. And next is let's put everything we create in this tool set so that those two tools, we're going to put them to the tool set. And if you take a closer look, you can see that this statement is actually a SQL query, right?
Yeah, exactly. What I really find interesting about this YAML file is that when you compare it to the Python code that we edited earlier with ADK tools, essentially what you're learning is two different ways.
So this is a tool. We are doing this earlier. We have to creating this in the Python function and then wrap them with this annotator. And here we are just doing them in the config file, right?
Exactly. Yeah, it's kind of declarative versus imperative ways of defining the tools. Yeah.
Yeah. Sorry, what did you find it interesting? You find it's very different.
Oh no, just two different ways of essentially defining tool sets. So you can do it through code. One, you're doing it more through through file-based configuration. Some people like different approaches, and each has their own benefits. But I just wanted to point out, essentially we're learning two different ways of building tool sets.
I was showing the cloud YAML file. It should be the tools YAML file. Great. So let's continue and continue to first create the secret by copy this and I'm gonna paste over here. So essentially what it does is first you need to create the secret, and you can see the secret on the secret manager, secret manager on Google Cloud Console. And here we have these tools. This is basically the tools you just created. If you're trying to view the source value, and this is the tools YAML file we created, right? And next is we want to deploy this to Cloud Run as well. So you just copy the deployment code and paste it to Cloud Run. And here, it looks like we're not using the Cloud YAML file. So here we directly deploy this toolbox because we have this toolbox image from this framework library, right?
Okay. Yeah.
Great. Let's take a look at what are existing tools that we deployed. Let's take a look at Cloud Run to see the current deployment process. And this toolbox is currently being deployed, and those are other tools that it's already been deployed.
Nice.
Yeah, so we're creating MCP server, right? And now we need to making sure the tool is working before we connecting that to ADK agent. And here is the command to diagnose, making sure the MCP server is working. So I'm copying this. I'm going to go back to the terminal. I'm going to paste it. So what it does is first it will activate the environment, and then it will install the necessary dependency. And then we have this ADK run diagnose. So ADK run is one way to run ADK agent. We have ADK web that open in the ADK web UI. ADK run is directly, you can interact them in the terminal. So here we are creating this diagnose agent that is just a testing agent connecting to our MCP server to test the functionality. And you can see that we're installing those dependency over here. And to test the tool, those are the, how you want to test the tool, Io?
So it's tested in the terminal. So as Annie mentioned, ADK run is one method of testing with ADK. And essentially what it does is spin up a terminal interactive kind of GUI
Yeah. I mean, how do
command line interface, yeah.
I mean, like anything you want to ask agent for using those tools?
Sure. Let's say look up the entry for Inferno Lash.
Look up?
What is the base power level? Yeah, let's start off with the first one.
Okay.
Now, it takes a little bit of time. So for those of you that are wondering, oh, my laptop or terminal is a little bit slow, don't worry. When you're running this for the first time, it's kind of establishing a lot of different environmental variables in the environment and a few other operations. So it may take seconds.
It works. Kyle. You can see we have this user.
Yeah.
Now you can talk to this diagnose agent by, oops, I said the wrong thing. I'm going to copy this. Paste. Look up the entry for Inferno Lash. Okay.
The base power level of Inferno Lash is 85 damage points. Pretty
great.
Good. Pretty good. So
that means it's using the MCP toolbox.
Yeah,
right?
I was about to say. So Annie, what's happening behind the scenes here? If you can just do a quick iteration, quick kind of.
It's actually using the MCP toolbox we created, and then it's connecting to that Cloud SQL, and it's grabbing this data like 85 damage, and then you're showing over here.
Yeah.
So next one. Okay, so it's casted this damage. Basically, it's dealing the 80 damage. We are actually connecting the API MCP server we just created to cast the damage. And the last one is we want to do some calculation. We are multiply with different magic so that now it charge to deal 45 damage. So we're using that general function MCP server so that it will do some calculation. And that means all three MCP server is working as expected, and we can finally connect them to the real agent we created, right?
Yes, that's so.
Yeah. I'm gonna Control C to abort it. And let's take a look at what we've done so far. So what we've done is we create MCP server, we create external API with ADK. We also have this MCP server with general function that has mathematical calculation, right? So those are created by ADK. We also try this MCP toolbox so that you create this MCP server that can easily access and modify or connecting to your database. And next is you want to connect those tools to ADK agent. And before we connecting, we need to know what are the ADK agent we want to create. So here we are creating this 5 familiar with sequential agent, water familiar with parallel agent, and the earth familiar with loop agent.
Yep.
So do you know what are sequential agent, parallel agent, loop agent on the screen?
Yeah, great question. Sequential parallel loop agents are a different way of coordinating essentially multi-agent architectures. And the ADK or Agent Development Kit comes with prepackaged, classes and syntaxes for how do you organize, multi-agent teams. So obviously the most raw and basic kind of coordinator example.
Sequential.
Yeah, is that you have a coordinator agent and then you have sub agents and you give it to it.
That's a hierarchical routing, right?
Hierarchical routing. That's the most basic, I would say, pattern of coordinator. And that will work for most of the time, but oftentimes for that use case, you have to prompt the agent on how you want it to call the agents and in what pattern. But if you really just have a deterministic pattern that you expect for the sub agents, we always recommend these workflow agents. So ADK is a sequential agent syntax where essentially, as long as you put the sub agents as part of that sequential agent, it will call agent A, agent B, always in that order. Similarly,
in the fixed order.
Yeah. Similarly for parallel agent, you may want agent A, B, and C to be running at the same time. And the best way of kind of coordinating that would be again through the parallel agent. The ADK makes sure that when that agent gets called, all 3 agents get delegated to it at the same time.
That's actually something ADK is very specialized at because imagine if you don't want to use sequential agent, you can just simply write a skill with workflow, or you can just in the prompt you say do A and do B.
Yeah, exactly.
But if you do the parallel agent in the prompt, you can say do them at the same time. It may not able to kick off the multi-thread, but with the workflow, it will definitely have those those running in parallel, and you get to control them. Like I think that's also one powerful thing from ADK that you can kick off parallel agent and also the loop agent. You can controlling the state that pass in the loop to do the check. So I think that's also one advantages of the ADK, right?
Yeah, exactly. And then lastly, just to kind of give a brief overview of the loop agent. The loop agent is essentially kind of an analog of the for loop. If for those of you programmers out there, sometimes you want to do something an X amount of times, And let's say you already meet the threshold for that criteria, you want to break out of that for loop. Similarly, for the loop agent, you may want a set of agents to be running the same set of logic up to a certain amount of time or a number of iterations, or if essentially they reach their objective. So ADK has really good syntax where you can set the max number of iterations, and you can also kind of escalate out of that loop if you meet your criteria. So essentially, those are the three sub-agent or three team agent patterns with ADK: loop, parallel, and sequential. And now Annie's going to walk us through now building each of these agent patterns in context of our use case.
Great. Thank you, Io. And let's take a look at the first agent, sequential agent. So basically, we want to have one Scott agent that connecting to that toolbox. Remember we have the toolbox have different type of fire ability, right? So we want to have a Scott agent to grab one type of fire attack, and then we want to have an amplify agent connecting to that general function. Remember general function doing the massive value calculation, right? So we want to have one agent grab the attack, another agent to amplify the impact. So you want to run them in sequential. So that's why we want to connect them in a sequential workflow. And here is how we do that. We go to step 5, domain workflow. And the first step is let's go to the agent file, agent.python file. So copy the file name. I'm going to go to this file, right? And let's first replace setup MCP. Then I'm going to paste it by this code. So here is how you can connect using this MCP toolset with this URL, so that you can connect it to the MCP toolbox server, like MCP server we just created. Why we have SSE server parameter here? Do we have different prompts parameter?
Yeah, great question. There's HTTP, there's SSE connection parameters that you can set. Essentially, you're just defining your connection with the underlying MCP server. So when you see that function tools URL, remember we deployed that server to Cloud Run.
You can take a look. Yeah. So it should be the toolbox, this URL, right?
Exactly. Yeah. So it has its own endpoint. So pretty much all we're doing through ADK syntax is defining that connection between that MCP server and the agent. And the way you do that in ADK land is MCP toolset. Yeah.
Great. And in the same file agent, let's replace this worker agent. Just copy this. And I'm going to paste it with the code over here. And let's take a look. So this is the Scott agent and amplify agent we just mentioned on the screen. So the Scott agent connecting to the toolbox, amplify agent connecting to this functional general MCP server. So let's take a look. The code, basically, we have the Scott agent. This is what the Scott agent does, and it's connecting to the toolbox tool. And the amplifier is connecting to the tool function. So that is the general function we just create. We don't have to create this one. This one is already created for you, but we check the code.
Yeah.
The next step is we want to put them together with the sequential workflow. So what we did is we created a Scott agent connecting to the toolbox. We created amplify agent connected to the MCP server. And next, we want to making sure they run them in a sequential order, right? So we copy this and we go to the replace sequential agent file and we paste it over here. So now we can making sure that we have sequential workflow agent that running those two things in sequential order. So if you swap the order, is that okay?
No, I mean, depending on your use case, you may have
in this case, you cannot.
No, this one you wouldn't want that to be the case because you want to break out and then amplify. But there could be use cases where it could be B then A or A then B. But for our particular use case, we care about the order. So hence the sequential agent.
Depends on your use case.
Yeah.
Great. So next, let's open an ADK web to test our agent. As you can see, we have a lot of command over here, but what you really care about is the last one, like ADK web. So those are just making sure you're in the right environment setup and you have the right variable configured, and then we can have this ADK web.
Yeah, and he's going to walk you through ADK web in a second, but essentially think of it as like a development UI where you can test your agents, evaluate them, interact with your agents, prompt them. So it's essentially just a nice UI for interacting with agents.
All right, Io, let's test the sequential agent we just created.
Let's do it.
So I'm copy this and gonna paste to the terminal. Oh, I can see that we are using ADK web. Previously, we were using ADK run. What are the difference?
Yeah, ADK run, essentially, you're in a command line interface prompting your agent. ADK web is a little bit more fully featured. It comes with a full development UI. You can prompt your agents, but you kind of see a visual response output. So this is really good for multimodal inputs. ADK Web, you can record your voice and do other things. You can also kind of do evaluation, see traces. So ADK Web is essentially your one-stop shop in a way for kind of testing and interacting with your agents.
Yeah, I really can't wait to see the ADK Web UI and to test it. So we want to first test the fire agent, and this is example prompt. I'm gonna prepare this.
Make sure that you navigate to ADK Web correctly. There's two different ways of doing it. So you can either click the link that gets generated, or if you're using Cloud Shell, so you're going to see an output that looks something like that. Make sure that you click the underlying link, and a new tab will pop up in your browser. Or you can kind of click the top right corner of your terminal, which Annie can show you, and kind of go to the web preview directly.
Yeah. All right. So now we have this open. I'm going to show you. This is a web view, and change port. Making sure change port to 8000 and change and preview. So it will open a new window. That is ADK Web UI. Great. So we can directly talk to our agent on the web interface. And on the top left, we have a drop down and making sure we select file for our current use case. And let's ask a question to fire agent, prepare this amplify strike using the infernal lash ability. And okay, let's see. It's doing. This is the agent. This is a tool, and let's see how the agent is going to do. So it will look up the available ability first. And from the result, it's getting the those are ability it gets. And then it's decide to use ability damage. It's look up again. Sometimes you just, using duplicate tool. But after the reasoning, it says, okay, the base damage is 85. Okay. So yeah, it's common to have some duplicated thing. And eventually, if you're using the amplify agent, so once it finds the agent you want to use, and then it's using the amplify agent to amplify the damage. So now you can see the final damage is 255. So that means we successfully run the sequential agent and connecting to the tools we just deployed to Cloud Run.
Yep.
And we are going to do a similar step for water agent and earth agent. So the water agent is, again, we'll go to the water agent file. So we go to the water agent file. Okay. And now I'm going to search it. So now I open this water agent file and copy this standard MCP, paste it. You can see it's similar. We are using a similar MCP toolset and connecting that to the corresponding URL, right? So that URL is the one that we deploy to Cloud Run. And in the same water agent, we're creating this agent. So we're going to replace this with the water agent code. And you can see we want to run those three agents at the same time. Basically, we want to have this Nexus channeler and 4-channeler all together, and then we want to merge them. And you can see that we have this parallel agent first on the left, and then we're gonna put together this parallel agent and the power merger to a sequential agent, so that we can make sure to run the parallel first and then the power merger next. If you run the power merger first and the parallel next, then it's not gonna synthesize the result.
Yeah.
So how are we gonna do that?
Parallel agent. So very similar construction to the sequential as we talked about. And all you do is wrap the sub agents in a parallel agent. Yeah.
So you can see we have those two wrapped in the parallel, and then we have this channel agent and the merger in a sequential. So that's how you put them, you run the parallel first and then merge them afterwards.
Yeah, and it's also really kind of a powerful pattern. A lot of people think that you can only put kind of basic LLM agents within a parallel agent or loop or sequential. But in reality, you could put a parallel in a sequential or a sequential within a loop. So it's kind of interactive.
Yeah, great. So next step is, again, we're also running this to do the ADK web, but I'm going to do the test later together. Let's go to the Earth agent. So Earth agent, similarly, let's go to the Earth file. It's under, I think it's under the Earth agent file. And similarly, let's first connect the tool to the, I think let's first connect the, here I'm going to copy the setup MCP server, and I'm going to copy this. And first, let's connect the MCP server to the agent. Similarly, we have this SSE server parameter, and we have this URL. So I noticed that we've been using this SSE server parameter for MCP toolset. Do you think we can also use the HTTP parameter for our connection? What are the difference?
Yeah, so SSE is meant for server-side events. So that's why we're using this in this particular case. But we could do it the other way too. But that's just essentially what we're doing for this use case. Yeah.
I see. So it really depends on the use case.
Yes. Sometimes you want something that's more streaming. So it really comes down to the use case. Yeah.
Got it. So we're creating this loop agent, and loop agent is first we're having this charging agent so that you're charging your energy and you're connecting this to the tool functioning, and then you're gonna check whether it's meeting the condition, right? So you're gonna run those two agents in a loop until the max iteration number is met, like it's maximum 2. You can make it 5 or 4, it's your choice, or it's meeting the criteria. Okay, now let's copy the charging agent and also this loop agent to our file. So we have this charging agent already copied, and then let's put the loop agent. So this is basically having this running in the loop. What do you think is a good use case in the industry to have a loop agent?
I've seen loop agents be used for different use cases, but one that comes up often is for writing use cases. Or essentially producer critique use cases where you have one agent that produces some sort of output content, another agent that critiques it, and then the producer agent then factors in that critique and produces a new version of it. So think about writing an essay. You have one agent that's essentially writing the output, another agent that's essentially grading it, and then the agent kind of then takes another try at improving the quality of the essay. You do that many times until you either reach a point where you feel like the essay is good enough and you stop, or you just give it a maximum of iterations. So that's just
Yeah, that's a really good example. Yeah. And let's take a look, because we test the fire agent before, and let's test the earth agent and the water agent. Okay. So the water agent, the parallel agent, right? So I'm gonna go back to the water agent. I'm gonna say unleash the wave of water. It's on the okay. So if you see this arrow, that means you need to refresh your screen.
Yes.
Okay.
Refresh your terminal. So essentially, after a while, the Cloud Shell authentication will time out. So you just have to refresh, and that kind of re-triggers an re-authentication. And you may have to close. Great. You may have to close the terminal again. I mean, close the APK web. But
I think it's okay.
Okay.
Let's give it a try. Unleash a tidal wave of power.
Yes.
Great. So it's supposed to run the parallel agent first and then the sequential agent next.
And it did so.
And yay! So you can also see the diagram over here. And we can also test the loop agent we just created. Yeah. And let's just go to the Earth and ask Earth agent a question. Begin charge and starting from 0. We expect them to keep charging until we have meeting the criteria. So it's charging starting from 0. Let's see whether it's having this in the loop.
Yeah. While this is running, what have you seen for parallel agents in terms of real world use cases? So everything that we're doing here has like a real world.
Yeah.
So what do you tend to see parallel agents used for?
I think parallel agent is similar in when we do a software design. We want to run things in parallel to improve the latency, right? So sometimes if things doesn't have dependency, for example, if you want to do a different type of search, like for example, when you plan the trip, you want to search for nearby museum, nearby food, or nearby concert, and then you can do the search at the same time and then synthesize the result. So basically, any type of task that you think they're not dependent on each other and you want to improve the performance, latency, increase, improve the user experience, you can consider running them in parallel.
Makes sense.
To do that together.
I like that.
And also very interesting, I also have a really cool project, like a collab that's using parallel agent. That's basically all the agent gonna vote, and then we're gonna pick the majority as a result. So if you're interested in that parallel agent use case, we can also link the code lab in over here.
Yeah.
Okay, let's take a look about the result. As you can see that they're running in a loop. So we basically keep charging, and check. So that means we have successfully finished all the type of agent. So we've been covered sequential agent, parallel agent, and loop agent. And we're doing the sequential agent like file agent, and parallel agent with water agent, and loop agent with earth agent. So thank you so much for everyone for attending today's session.
Yay.
And tomorrow, yay! But we haven't filed the both yet, right? So what we cover today is we cover different type of MCP server with ADK and MCP toolbox. And then we link
workflow agents, as well.
Yeah, and then we have this workflow agent from ADK, right? And then we link the different type of tool to the agent. So now we have the specialist agent. So what are we going to cover tomorrow, Io?
So tomorrow we're going to be covering agent-to-agent protocol, or A2A. We're going to be covering plugins and callbacks in context of the ADK. So how do you inject custom logic at certain parts of the agent runtime before an agent is called or after. We're also going to learn a little bit more about agent state and memory. So it's a jam-packed session tomorrow. So please, tune in again.
Please.
Yeah. So until next time, and also tomorrow we're going to be fighting the boss in the clouds. You don't want to miss that.
Fight the boss.
Yeah. But until next time, thank you for joining, and we'll see you next time.
Thank you.
Thank you.
Bye. See you next time. Bye.
Hello, hey.
Yeah, welcome back to our hands-on AI, where we walk you through step-by-step for AI practical labs. I'm Annie.
And I'm Io.
Yeah, so this is 2-part episode series. So for yesterday, it's a part 1 that we went through everything from MCP server to ADK agents and workflow ADK agents. And if you're interested in that part, making sure you check day 1, like yesterday's content. And today's content, we're going to talk about agent-to-agent protocol. Io.
Yep. Yeah, so today we're going to be covering A2A, agent state and memory. So it's a jam-packed session. So let's dive into it. So I'm going to go ahead and share my screen.
Before we dive deep into it, if you're missing yesterday part, making sure you check yesterday part, because you need to claim your credit there and also need to do the setup there. So you can listen to today's episode. However, if you really want to do things step by step and make the demo work on your machine, making sure to check yesterday's replay. And Io.
Exactly.
Please take over.
Yeah. So everything that Annie just said, but I'll go ahead and share my screen and dive through the architecture that we're building today.
Okay, let's start.
So you should be able to see my screen now. So yesterday, what we did was deploy 3 separate workflow agents, one for the fire familiar, sequential agent, one for the water familiar, parallel agent, and one for the earth familiar, loop agent. And they're all being coordinated by the summoner agent. That's essentially the orchestrator in this particular workflow. But that works really well for the most part. But you can imagine use cases where, let's say the summoner is being deployed as a separate microservice on a separate endpoint or app. And then each of these individual familiar agents are being deployed on their own service as well. For those use cases where you have remote agents communicating with each other, you need some sort of protocol that kind of enables that. And that's where agent-to-agent protocol comes in, or A2A. A2A is essentially, it equips each agent with its own resume and makes it discoverable by other agents.
Okay.
So agent card, so when I say agent card, what comes to mind, Andy?
Yeah, it's like a name card. Like when I first time I meet you, I'm gonna say, hey, this is my name card. This is what I'm good at. This is what I can offer and how you can contact me.
Exactly. Right? Yeah. So each agent card, which is essentially a discoverable JSON at a well-known path for each agent at the deployed endpoint for each agent. Essentially the capabilities of that agent, the skills, and it also something for it's important for authorization and security is how can you authenticate with that agent. So you may not want anyone to be able to call that agent. A2A actually enables what you call security schemes, where I can set API keys or other OAuth mechanisms where only the personnel that I want to authenticate against that agent authenticates. So essentially that's A2A. So again, what A2A is facilitating behind the scenes is each agent has their own agent card, and that's initialized and made available by the server.
Okay, so it's like I have many agents there. They all say, oh, here's my name card. You can get to know what I'm good at, how to contact me, so that the client side, the workflow agent can first understand, okay, what are the available agents in this space, and then read their name card. and decide, okay, who I want to contact to, and then how do I contact them?
Exactly, yes. And that's, you pretty much just covered client discovery. Then essentially that root agent, or essentially the consumer of those root agents, essentially discovers all available agents by retrieving their stored agent cards and essentially looking at the descriptions of what each agent can do and its skills.
Yeah.
And then finally, as part of the runtime of the agent, as the coordinator runs into a use case, it may call one agent or invoke it based off of the instructions and based off of the description of the agent. So it's going to kind of do semantic selection of what agent is best to use for a particular use case. But overall, it's the same exact concepts of what we learned for the local agent, but all essentially we're using A2A to kind of facilitate the remote agent approach, where essentially agents can now be discovered across different endpoints. So now going back to the lab, so now that we've kind of covered a little bit of the architecture, now we're actually going to go ahead and actually build that through code. Where essentially, we're going to enable each of those familiar agents with their own A2A endpoint that makes available agent card.
Maybe we should give our audience an overview of what is the thing for this collab or for this lab. So in case they're just first time diving in, like they're confused, okay, why there's a magician there holding a fire, right?
Oh yeah. So for those of you that are just tuning in for the first time for day 2, as Annie mentioned, it's really important that you kind of go through day 1 first. We kind of walk through a lot of the environmental setup as well as the context of the lab. But just to do a quick recap, essentially for this lab, we are building a summoner agent that at the end is going to fight a boss.
Yeah, we're going to fight a boss.
And that boss is essentially another agent. So that monster that we're fighting is actually an agent that's going to communicate with our summoner agent via A2A. So essentially A2A is embedded all throughout this lab. So overall, what we want to do first is kind of equip our summoner agent with all the tools and agents that it needs. So that's the process that we're going through right now. So that said, as mentioned before, what we're going to do now is essentially enable each of our familiar agents, fire, water, and earth, with their own A2A endpoint. So essentially it can be exposed as its own endpoint and then consumed later on by the summoner agent.
Yeah, so someone can later on contact them through that URL.
Yeah.
Even though they're deployed, they can connect. Oh, I'm curious when you do. I think you're not sharing your screen for your Cloud Shell.
Yeah, I'm not in the Cloud Shell yet. I just wanted to first walk through the code. Yeah, so here's where we should be in the collab. So make sure that you are at step number 6. That's where we are. And then what we're now going to do is very simple. You're going to see that the syntax that we're going to add is no more than a few lines of code, but from agent to A2A, import to A2A. And then essentially all we're going to do is grab that agent, variable name, pass it into the essentially imported function to A2A. Essentially what this is going to do behind the scenes is make sure that endpoint has the agent card at the well-known path. And that's pretty much it. And then at first we're going to test it and run it locally. Then later on, we're going to deploy each of these agents to Cloud Run, and then essentially have them each running on their own Cloud Run endpoint.
Let's do it.
Yeah. So essentially, this is where we left off yesterday.
Zoom in.
Go ahead and clear my terminal. And again, we're going to be opening up the editor for this particular exercise.
Okay. I'm curious, when we say we have an agent card, right? How do we get those information? Like you mentioned about the agent skill, what this agent can do. How does the agent card understand, like having those related information, has a good summary of what this agent can do?
That's a great question. Okay. So as Annie mentioned earlier, when we were building out the agents all those criteria that you add to the LM agent, such as the name, the description, the instructions, these all essentially via the to A2A function, these are converted into A2A compatible specs or the agent card that other agents can consume. So it's also really important as an engineer that when you are defining these agents, you're being very clear when it comes to description. And
maybe we can give an example. Maybe you can go to a fire agent and show us the fire agent. Like what does it look like?
Oh yeah, great question. So great points. Yeah,
like
so
go to.
Yeah, great point. So this is the fire agent that we built out yesterday. So we have the scout agent, if you recall, and then the amplifier agent and the sequential agent path. So you can see that we're being very detailed. We're giving it an instruction. We're giving it a very clear name. These are all translated into the actual kind of specs that appear in the agent card later on. And we'll actually take a look at an example agent card by calling in the endpoint of one of these models. But one of these remote agents later on. But essentially, that's what you want to make sure is very clear as part of your definition. But
sorry, sorry to interrupt. Please go ahead.
No problem. Yeah, but as mentioned before, we're only going to be adding a few lines of code, and that's kind of the power of the ADK and its integration with A2A. Again, all we're going to do is import the to A2A package, and then we're going to be using Uvicorn as essentially like a development runtime server, so we can test it locally. and run the app. But that's pretty much it. So all we're doing is converting this root agent to A2A, and that's it. And again, it's going to be running port 8080. Okay, moving on. We're not going to do the same exact things through all our familiar agents. So we just did fire. Let's go ahead and do earth. So again, I'm going to go over here to the agent.py file. I'm going to scroll all the way down. We can see all the previous code that we entered yesterday. Now I'm going to do the same thing. All I'm doing essentially is taking that root agent, which is essentially the loop agent for earth, for example, and then I'm passing it into the 2A2A function, specifying the port, the public URL, and the UV query run, and that's pretty much it.
And so that clients, when we discover them, they can have this URL and discover those agents from the server side, right?
Exactly. Yep. Yeah, so that's pretty much it. And then now I'm going to do the final thing with the water agent. So we just edited the fire agent, the earth agent, and let's make sure that we update the water agent as well.
Sure.
I'm going to scroll down here. And again, we can see all the previous sub-agents that were defined for the water agent. We can see the, again, root agent definition, which is a sequential agent for water. But then we're just going to do the same thing here where we say from agent to A2A, import to A2A. We are going to pass in the root agent. And again, that's pretty much it. It's really simple to essentially enable your agents that are defined with ADK for A2A.
Yeah, so now they can all have this URL. That's,
Yeah. Okay.
It's discoverable. Yeah,
so now what we've done is define this code locally for all three of our sub-familiar agents. And now what we're going to do is now essentially deploy each of these familiar agents to the cloud, so they each have their own A2A endpoint. So one will have its own Cloud Run service, the fire have its own Cloud Run service, water own Cloud Run service, same thing with the earth. So I'm going to go ahead and run this here. And if you recall, we talked about Cloud Build before. Again, Cloud Build is like the CI/CD engine for Google Cloud Services on Google Cloud. You can use it to automate different build steps. So that's what we're going to do here. And we'll take a look at the Cloud Build file as well. So I'm going to go ahead and save it.
What does the file look like?
Yeah. So here's what the fire looks like.
Did you paste to the terminal?
I haven't pasted it yet, but I just wanted to kind of show you what it looks like. So it's going to take a few, maybe 2 to 3 minutes. But the reason why it's taking a little bit of time, you can see we're automating a lot of steps behind the scenes. We're building the familiar image simultaneously. We're storing the artifact in artifact registry, and then we're deploying the 3 services in parallel. So we're deploying each of the familiars to their own Cloud Run service. And that's pretty much it. So there's 3 steps or 3 to 4 steps being automated, depending on how you count. So now that we know that, let's go ahead and it looks like my screen froze. I'm going to go ahead and refresh.
Sure. Yeah, it happens sometimes on Cloud Shell.
Yeah. Okay. So we know what the Cloud Build YAML is doing. So going back here to the terminal, I'm going to zoom in so you can see it closely.
Yay.
And so again, I'm just going to be running that Google Cloud Build submit Cloud Build.yaml file. So essentially it's building the container image behind the scenes. And also we have a little bit of other environmental things that are part of the code lab. So essentially we just want to make sure that your environment has all the variables that it needs, such as the DB name and username for the toolbox that we defined earlier. Right now, you notice that the fire URL, water URL, and earth URL is still blank. That's what we expect. We haven't deployed anything yet. But later on, when we actually take a look at these variable names, they're going to have each their own, essentially, Cloud Run service endpoint. But overall, so everything is running so far. And let's go ahead and see how things go. So again, this
I am curious about the reading. So you said that A2A that allow agent-to-agent communication, right? What if I deploy one thing on Cloud Run, another agent maybe at a different like place, like for example GKE or like different cloud, a different like maybe agent engine, like can I still using A2A to connect?
Oh, great question. So the nice thing about A2A is it's a universal protocol for agents that are not only built with ADK. You can build your agents with Crew AI, LangGraph. These are other popular agentic frameworks. As long as, again, you're deploying with A2A compatibility, which means your agents have a well-defined agent spec or agent card. Essentially, you can build your agents with any agentic platform and still leverage A2A. So that said, it doesn't also matter where your agents are deployed. You can have your agents deployed locally or on-premise, which is the same thing, or on the cloud, such as GKE or Cloud Run. Again, as long as they all are complying with A2A spec, they can communicate with each other. So you tend to see use cases, for example, like an on-device agent. Let's say I have a device agent that's running locally. I wanted to be able to access my private data, but I don't want cloud agents to be able to do so. Oftentimes you see people running agents locally and then communicating with their agents on the cloud through A2A. So that's just one example.
Oh, that's really cool. But I also heard a lot of people are asking me, oh, can they just use MCP? What's the difference between MCP and A2A?
That's a really great question. And I actually have a slide for that as well.
Oh, can we see that?
Oftentimes people wonder if A2A is competitive with MCP or is it collaborative. I like to look at it as a collaborative kind of aspect, where A2A is really good for enabling agent-to-agent communication, where MCP essentially enables tool discovery and tool communication with your agents. So think about agents for agents, and with A2A, and then tools for agents, which is MCP. And there are kind of like edge use cases where technically you could use an agent as a tool and have that be kind of via MCP. But overall, what I found is that A2A is better for those use cases. Actually, no, if you're using an agent as a tool, you may have good success. But if you intend to use an agent as an agent, which means stateful delegation, most of the time you want to use A2A, because A2A has a lot of built-in measures for kind of enabling, polling for long agent responses of that nature.
Yeah. Also, agent as a tool means, as you you mentioned, that agent has a state, but if you have using agent as a tool or MCP server, it's stateless, right? So it doesn't have the state control.
Exactly. Yeah. So again, A2A complements MCP. They're not kind of competitive, and oftentimes in most production use cases, you tend to see a mixture of both of them being used. So that said,
I wonder before A2A, if I deploy my agent to cloud, then how do I communicate to the service I deployed?
Oh, great question. Before A2A, again, there was different standards. There was things like ICP and but the nice thing about A2A is it kind of creates a universal protocol for how agents can communicate. But before A2A, we tended to see within each organization there was their own method of exposing agents, and it wasn't really universal. So, which kind of makes it less effective for different use cases, like a payment network agent. Or let's say you want to have an agent make payments for you, and has to be able to communicate with some sort of consumer agent on another side. Again, you want to make sure that every agent across most organizations are using the same protocol.
Yeah. That's a great summary, and also that's exactly why we want to use A2A, right? I saw they're deployed.
Yeah, it's deployed. So, so our cloud build service worked. And if
let's take a look.
Let it work. We can go over here to Cloud Run, and then we can go over here to Services, and you can actually see it there. But overall, so remember our Agentverse dungeon. We're going to come to that later on in the lab. That's essentially where we're going to have the mini boss fight. So that's good to go.
Yeah.
We have the API tools MCP. We deployed that in day one. And then now we have the Earth familiar, the Fire familiar, as well as the Water familiar as new endpoints that had been deployed. So now we have each of these familiar agents that are essentially, I believe, a parallel, a sequential, and loop deployed to their own Cloud Run service. So that's great. So now that they're deployed to their own Cloud Run service, that now means they can be consumed as remote A2A agents. So that's the next step of our lab, is enabling our root agent, the coordinator, to essentially consume these remote agents as A2A remote agents. So let's see what that looks like.
I remember we have the orchestrator. So basically, it's a hierarchical routing pattern to connect to the summoner, connect to them, right?
Exactly. Yes. Yeah. Yes.
Oh, yeah. I guess we have to first connect them.
Yeah. So that's the next step. So going to our summoner file, what we're now going to next add is essentially the remote A2A agent syntax for connecting to a remote agent with ADK. So essentially that syntax is essentially as simple as remote A2A agent. Again, the same name that you provide for local agents, you have to provide that. Description of the agent, then the agent card. So essentially you're going to be passing in the URL of where that agent is deployed. And then the agent card well-known path is actually something that comes pre-packaged as part of like the A2A library. So you don't specify it. It's kind of like a well-known path that's kind of standard for all remote A2A agents. So
we're going to see that later in our example, right?
Exactly, yeah. So that's how other agents know where to find the agent card for each A2A compatible agent. So I'm now going to go to summoner /agent.py in the editor. So now navigating back to where we were.
I don't see our terminal. Oh, I see it now.
Yeah, so coming back over here, I'm going to make my screen a little bit bigger. I'm going to go to the summoner.
Can you zoom in, IO?
Yes.
Thank
hopefully
you.
This is closer.
Yes,
so agent.py, and there's still a few placeholders in our file that we want to essentially edit. So the first thing we want to do is essentially define our remote A2A agents. So as I mentioned before, the ADK A2A package makes it really easy for us. All we're doing pretty much is importing the remote A2A agent class from the library. And again, we're importing the agent card well-known path from the library as well. So these are two things that we're going to be using as part of our definition. And coming back over here, I'm going to copy this, as I mentioned before. And then coming back to the lab, I'm going to paste this here. So now we've just defined our remote A2A agents, one for fire, one for water, and one for earth. Lastly, or not lastly, but next, now that we've done that, we are ready for actually defining our root agent in the summoner. So let's take a look at that. So again, regardless if it's a remote agent or a local agent, there are a few definitions or parameters that you need to have as part of your agents. You have to have a name, so orchestrator agent, a model, Gemini 2.5 Flash. We're giving it a set of instructions. And then now we're passing in the remote A2A agents that we defined as sub-agents into our orchestrator or coordinator agent.
Yeah, this is like a broader pattern, right? So we have the orchestrator, like you can decide, okay, what is the familiar I want to delegate to? I can delegate to fire agent or water agent or earth agent, and I'm connecting them through those URL and understand when to use them and how to use them by reading that agent card. And we can also, like here we're using LM agent, we can also use a workflow agent like sequential agent or parallel agent here. And then also similarly, just if we can, as long as we can discover other agent server, like other agent through their agent card and their URL, and then we can also using workflow agent here to connecting them.
Exactly. Yeah. That's a really good explanation summary. So I'm going to go ahead and copy this here, and then come back to the cloud editor, and then make sure that here, and don't worry about this save last summon after tool. We're going to get callbacks later on.
Really soon.
Yeah, but I'm going to, and again, I like to always paste the code below the placeholder. Some people like to replace it, but I like to know where the placeholder was. So that's pretty much just the placeholder here. Yeah, that we're putting here. So root agents equals to this orchestrator agent. And then don't worry about A2A because it's already, the code is already there for that in this particular file. And that's pretty much it for this step. And then now, if we want to verify if things are working, let's think about what's happening behind the scenes. So I'm going to go back to the architecture of what we've built. I'm going to switch to my slide. Give me 1 second to pull that up. So again, this is what we're building as part of this step of the lab. So so far what we've done is create three A2A familiar agents, deployed it to Cloud Run. We've also now configured the summoner agent so that it consumes these A2A agents. And then now ideally, if we were to do ADK web, essentially, even though these agents are deployed to different services, they can still communicate as if they were in the same runtime. And that's what we're going to see in a second.
Okay. So we're going to test agent with ADK web.
With ADK web, which again is a development UI for ADK.
Yeah, for those of you who was not there yesterday, we also covered another way to run ADK is with ADK run. So basically, you can directly talk to agent in terminal. But with ADK web, you can see them in the interface. You can interact with them and troubleshooting in real time.
Yep. Okay, so now I'm going to go ahead and paste that ADK web command here.
Thanks for zooming in. I need my glass. So I see we are install some requirement dependency over here, and then we start ADK web with this command.
Yeah, and if things are working, if you recall, before we deployed the agents, these variables were blank.
Yeah, now we have those URL because we have this remote A2A agent now.
Yep.
I'm curious. I really want to see the agent card. When can I see agent card?
It's coming up in a second. So we'll go through agent cards.
Okay. Yeah. Be patient, everyone.
Yeah.
Ayo, how would you describe yourself if you have an agent card? If you're an agent and you have an agent card.
That's a good question. I think, like as I mentioned before, I think agent cards are pretty much like the resumes for agents.
I mean, describe yourself.
Like the same way that you describe yourself on social media. So think about like an agent card being the Instagram for the Instagram page for Instagram profile for an agent. That's how I like to look at it. So I guess my social media is kind of like my agent card. Okay, so it deployed.
I will skill coding agent expertise.
Okay, so again, if you want to open up the ADK web, either click the link that comes up where that's right here, or you can go to the top right corner and go to web preview and make sure that you match the port number with the 8,000 report that was produced, and either one will kind of take you to the ADK web UI. Now that we're here, make sure that you select the agent you want to test. So right now we want to test the summoner agent.
Yeah.
And so that will bring us here. I'm going to zoom in just so you can kind of see the prompt a little bit more. And let's go ahead and test it. So I'm going to present it with a monster and allow the summoner architect to essentially choose what familiar agent works best for that particular monster. Again, we're trying to train ourselves for the boss fight later on. So we want to make sure that our summoner agent chooses the right familiar to attack the right type of monster.
Sure. Let's see what summoner choose.
So I said hype. It's a single slow-moving target with thick armor weakness. Is inescapable reality.
What's familiar should they choose?
So you can see that here it transferred to the fire familiar. And then you see the delegation here. It delegated to the fire. And you can kind of see the input prompts, the output prompts. You can see that it was A2A facilitated. So it was through A2A message that was sent, as well as the outputs. You can also see the token counts for those of you that want to debug things like cost. It's all available through the ADK web by ADK tracing. But overall, it's working pretty well. So we gave it a hype monster, and it's using fire familiar for that. Let's try one more prompt as well. So if I were to give it another monster, let's see what it selects for that. So Dogma Apathy, a rigid stone-like inquisitor made of ancient rulebooks and enforced processes. Weakness is unbroken collaboration. So what comes to mind when you say unbroken collaboration?
Unbroken. I don't know.
We'll see. We'll see what agent gets selected.
Are you playing RPG game? I guess you have to play the game to know more strategy, right?
Yeah.
Are you one of those RPG game player?
A little bit.
A little bit.
Yeah. So it looks like it's taking a little bit to generate the output. And we'll
Maybe we can take a look at the console to see the output.
All right, so we can see that the output got generated. From the fiery depths to the icy peaks, I gathered the scattered energies. So we can see that the orchestrator agent delegated to the water familiar. That kind of makes sense. Unbroken collaboration, and then it routed to the parallel agent familiar, which makes sense. And it gave about 500 damage. So overall, it looks like our summoner agent knows how to fight monsters, and we're getting really prepared for the boss fight coming up.
Yeah.
Yeah.
What's next?
So what's actually, and for those of you that are following along, you can go ahead and test one last, input. See if the Earth gets triggered. You should see the Earth familiar get triggered for this one. But since we already did two tests, actually let's go ahead and do it. And while that's waiting, I can actually show you an agent card example that Andrew was asking for. So
can't wait.
Yeah. So coming over here, we're going to say obfuscation, and ideally, again, elegant sufficiency. So what comes to mind when you think about that? I'm thinking loop agents, but overall, what you see here is the Earth familiar get triggered. So it's taking some time because, again, there's A2A communication happening behind the scenes.
Yeah.
It's delegating, responses being generated. So it takes a few seconds. But again, while this is being generated, let me show you an example agent card for the same exact agent. So if you were to go to the Earth endpoint, familiar endpoint for this Cloud Run service. So again, all we're going to do here is come over here to the.
By the way, we cannot see your tab. We cannot see your. Oh, okay. Yeah.
Yeah. So again, if you recall, so this is the deployed endpoint for the Earth familiar. So this is like the live HTTP endpoint. And remember, we talked about the well-known path. So if you ever want to find the agent card deployed agent, you just go to the endpoint and then go to .well-known.
I cannot see .well-known.
Oh, so since I'm sharing my screen, you can't see it, but let me put it in the terminal so you can see exactly what I went to. So here's the URL that I went to. So again, it's just
I don't see our terminal.
Oh, thank you for telling me. Thanks. So again, all I went to is the Earth familiar deployed endpoint. So this is just like the base URL. And then, and this is standard for all A2A .well-known /agent.json. and that will then essentially show you the agentic JSON agent card for that agent. So here you can see capabilities. I can see that it is the Earth Elemental Familiar. I can see the workflows that it supports, such as the loop workflow. I can see the description. This agent will execute the charging agent, and so on. So essentially, these details are essentially the resume for this agent. And as I mentioned before, A2A also supports security schemes. So if I had supported things like OAuth or API keys, I would see that definition here. So other agents know that if I want to communicate with this agent, I have to first authenticate against it. Yeah. So essentially, this is like really good. And maybe let me pretty print it so it's easier to read. I should have done that earlier. But here you can kind of see a better, kind of clearer view of the agent card for this particular agent.
That's really helpful. Thanks for showing us.
No problem. Yeah, so that said, let's go back to the output of the ADK web. So I can see that I'm the unyielding bedrock of the mountain's core. Let's see what got delegated to. The orchestrator selected the Earth Familiar. And again, you can see in the logs that it was facilitated via the A2A communication, the A2A request, and A2A response. So, and there's multiple parts to the response. So again, that's some of the benefits of A2A, is that it's kind of optimized for that polling and multi-part output and input from these A2A agents.
Got it.
Yeah, so overall, everything's working. Our summoner is able to invoke each of our sub-familiar agents and are ready for the next step.
Yeah, let's do. What's the next step?
Yeah, so coming back over here to the lab, our next step is imposing the laws of magic, the interceptor pattern. And let me break you down what this means in a very simple way. So essentially, and to do that, I'm going to come back over here to the slides, and we're going to now introduce the idea of callbacks.
Callback.
So Annie,
My favorite.
Can you explain what like a callback is for like the audience? Like, when would you use it? And let's start simple. What is it, a callback?
Yeah, so basically, agent has a life cycle. So agent has a model to decide what tool to use, and then like maybe pick a different tool, right? So before the agent start, before the agent start using the model, before the model is using the tool, and after the model is finished using a tool, after model decide, okay, picking another tool, and after, okay, the framework finish using another tool, and then like finally this agent finish the whole process. So like at every part, like every point it's through this whole life cycle, you can intercept it and adding your own custom logic. And that is what we call callback. And as you can see on the screen, we have this before agent callback, before model callback, and after tool callback, after agent callback. So basically, you can add in your own custom logic there. For example, you can manage state or include guardian or adding control at specific point of this whole life cycle. And a good example, like IO had a really great lab about, agent security with model armor. So basically you can adding agent like a model armor to before agent callback to protect your agent. Maybe you can explain more, IO, on that example?
That was a really great definition and explanation. Yeah, so as Annie mentioned, these callbacks are a great way of injecting custom logic at different points of the agent lifecycle. And you can do it for different reasons, such as security. Let's say you want to use something like model armor, which is Google.
Maybe we explain what is model armor.
Yeah, so model armor is essentially like a callable API that you can use to filter inputs and outputs in general. So you can imagine having an input, and before it being passed to the agent, you want to filter for any malicious inputs. So you pass it to model armor, and it would check for any sensitive data, any prompt injection, and so on. And if there is detected there, essentially it will filter it out so the agent doesn't see it. Similarly, sometimes these agents can leak data that they're not supposed to. So again, you may want to have model armor after the agent is called and essentially check for any sensitive data there too. So you tend to see model armor used in these callbacks as well.
Yeah.
So overall, in this next step of the lab, what we're going to do is essentially design our own callback, but not for security per se, but it's essentially optimize efficiency of our models. And when we say efficiency, let's imagine that when these familiars get called, you want to make sure that essentially that their environment is ready for the next call before you call them again. You can imagine a use case such as spam. You want to prevent someone.
I want to keep having attacked. Exactly. Keep using.
You want to make sure that the agent is essentially cooling down and given enough time to kind of respond to the next one and has the resources that it needs. So essentially what we're going to do is inject our own callback that essentially checks to see when was the last time the agent was called. If it's less than a certain amount of time, essentially it doesn't allow the call to go through and it blocks it. Otherwise, it allows the call to be called, the agent to be called. So essentially this callback is essentially custom logic to just kind of look at the last time the agent was called and then do something based off of that. Yeah. And then before we jump and move forward, there's also the idea of plugins in the ADK. And think about ADK as the global version of the callback. So for callbacks, as you will see in the code, essentially you define it at the agent level. So I can define a callback for one agent, but not for the other agent, which can be good for customization. But let's say you want to have like a rule that's applied globally across all your agents. It's simpler to sometimes just define one ADK plugin, which you then have it run against your entire ADK runtime. So all agents get affected. So essentially think about plugins as the global version of callbacks.
I see.
Annie, do you tend to use callbacks more often or plugins in your applications?
Oh, I tend to use callback because oftentimes it's like, for example, you want to add a state control. So it's easier if you it's necessary that you're adding callback to a specific agent to manage the state control, right? So that's yeah.
Okay, so let's go through the code. So we just defined what callbacks and plugins were. So let's think about what the code looks like. So essentially, you're creating a custom function. We're passing in a callback context. And again, this is SDK, ADK language or syntax. And essentially, again, as I mentioned before, we're checking to see the last time that agent was called. If it's less than a certain amount of time, you kind of implement your own cooldown logic and wait for it to cool down. If it's more than that time has passed, then you allow the call to go through. And that's pretty much all we're doing here in the logic.
Yeah, I can see that in real life use case. We can use the similar check cooldown to prevent throttling the service, right?
Exactly, yeah. So coming back over here to Earth Agent, that's going to be the first. That's where we're going to implement the callback or the cooldown period. And you're going to find the before agent function here.
Okay.
And we're going to define our callback. So again, check cooldown. We just want to see the last time it was called and implement our own callback logic. So that's what we're doing there. And then the next step, what we want to do is essentially add this before agent callback to the Earth agent definition. So before we talk about there being different parameters that you can add to agents, we talked about name as one being a standard, model being a standard. What's also available for these agents is callbacks. So let's actually take a look at that now. So essentially, I'm now defining a before agent callback parameter that I'm adding to the loop agent. And if I wanted to do after agent callback, it would be very simple. It would just be after agent callback. And then I would add the same cooldown function if I wanted it to be, and so on. But overall, all we care about for now is the before agent callback.
Sure.
Okay. So far, what we've done so far is create the callback logic, and now we've passed it into the loop agent.
Great. I want to see, does it actually have cooldown? I want to see how it works.
Yeah, so let's go ahead and do a quick test. So now we're going to go ahead and do the ADK run of our Earth agent this time. So again, not ADK web. Again, when you do ADK run, you're essentially spinning up a kind of a terminal kind of command line interface interacting with the agent.
Let's see, what does it look like?
Yeah. So coming back over here to the editor, I'm going to come over here to the terminal again. And let me kind of exit out of that ADK web logging. And I'm going to go ahead and paste that. So ADK run Earth. And it's going to, and again, so what I see here is G-Cloud. I caught it early. I probably should have let it go through. But again, if you see this error, like G-Cloud is not authenticated, or you may see something like service account email is not logged in, that just means your terminal has lost authentication status, and you just have to refresh your browser. So I'm going to go ahead and refresh now, and that will kind of
the security. It's for the security configuration that Cloud Shell will automatically expire after around 30 minutes or so.
Yeah. So now I just reran the same command, and this time you can see that G-Cloud is authenticated. So
yay!
And again, all these exported. That's because we ran the command. This right here, we just want to make sure that since we were refreshing, we understand that people are going through the lab in multiple sessions. We want to make sure that you have all the environmental variables that you need. So each time we kind of have you source it. But that's the reason why it's taking a little bit longer. ADK run by itself is actually pretty quick, but we're kind of like doing a few things before that.
Yeah. So if we do a callback and also a plugin at the same time, does that work? For example, I have a callback in the before, after to callback. And then for the plugin, I have like before agent callback. If I do both, does that apply to both?
Yes, yeah. Yes, it applies to both. Yeah. So yeah, so again, you can define globally applied policies or logic through plugins, and then have individual callbacks through the callbacks that are applied directly to each agent. Okay,
That's cool.
so now that we have created that, let's go ahead and test it. So I'm going to say something like, begin the seismic charge starting from 0. And what I should see get triggered behind the scenes is a few things being produced by the Earth agent familiar. So you can see that it's kicked off a few things, such as the ground trembles as seismic energy is absorbed. Again, it's going through the loop process that the loop agent has. And overall, what we've done so far is essentially invoke our Earth agent.
Yeah. And we're ready to spam our attack to test the cooldown feature.
Yeah.
Right?
And you can actually see that it's actually working already. So you can take a look at the logs and callback. It already checked to see if it was called within a certain amount of time. Obviously, since we've called it in a few minutes, it proceeded because we haven't called it back to back. But now that we just called it, I'm going to say the same thing again, and about 5 seconds later.
Quick. We're going to over the 1 minute window.
Yeah, so you can actually see that it says cooldown active for Earth Elemental Familiar, terminating with message. The Earth Elemental Familiar is exhausted and must recover its power. So you can see that now we've implemented our own throttling logic.
Can you try spam it and see?
Okay, we'll see if we can kind of break it.
Okay, I guess it's already past the 1 minute window.
Yeah, so the 1 minute passed as we were talking, but you can see that it did get blocked when we called it within that threshold period. So that's exactly what we want. So it's essentially just a good example of how you can implement your own custom logic and have it be implemented as part of the agent lifecycle. So people do this for logging sometimes. They do it for security, as we talked about before. So there's different reasons to have callbacks. Okay, so we can exit out of that and proceed with the next step of the lab.
What is next?
Okay, the next step of the lab is you can actually test the same thing with the ADK web. So you can actually do the same thing.
Optional?
But it's just optional. You just want more of a visual interface. Next thing that we're going to do is, rather than just defining cooldown just for the Earth agent, as mentioned before, plugins are a great way of globalizing logic across all of your agents. So again, if you have any organizational rules, define it as plugins rather than callbacks if you want that global effect. So now what we're going to do now is define that same cooldown, but as part of a plugin, and then we're going to add it as part of the runtime. Okay, so here's the cooldown plugin logic. You can see we're importing the base class from the ADK base plugin. We're defining our cooldown logic. And again, plugins essentially wrap individual callbacks. So essentially, we're defining a new before agent callback that's part of the cooldown plugin class. And we have the same kind of cooldown logic where we check the last time it was called. And yeah, that's pretty much it. So let's go ahead
and then we want to install this plugin to Runner so that you apply to all the agent that's powered by this Runner, right?
Exactly, yes. So let's go ahead and define this cooldown plugin. So
let's
here to the code, and then we want to find the plugin file. So I'm going to zoom in so you can see it.
Yes, please.
And then you see this cooldown plugin file right here, and this placeholder, replace plugin. So again, the cooldown period is about 60 seconds. And if you want to change it, please feel free to. But I'm going to leave it at 60. And that's pretty much our cooldown plugin, where we have the plugin defined. We're importing, again, the base class from the ADK, defining our class level callback, and that's pretty much it.
Yeah.
Moving on from there, what we're next going to do is actually then pass that same plugin that we just defined into the runtime definition of our ADK runtime. But before we do that, we don't want to have 2 cooldowns for the Earth agent. So we're going to remove that individual callback that we defined for the Earth agent before. That was just a demonstration of how callbacks work. So coming back.
I wonder if you have 2, does that has 2 minutes cooldown then? Because it was sugar tight.
That's
sugar tight.
Yeah. That's a good experiment for anyone who wants to test.
Please.
Go ahead and save it. So again, I commented out the before agent callback. Then I come back over here to the lab, and then I'm going to go to the agentverse architect agent to a2a.py file. Then I'm going to go ahead and add this import. So let's go ahead and do that now.
Oh, I don't see your editor. I see your editor now.
Yep. Okay, so we just defined the location of our local cooldown plugin. We're importing the class. And the next thing that we want to do is essentially add that plugin to the plugins list for our ADK runtime. So I'm going to go ahead and copy this here and come back over here to the code and scroll down to the next placeholder right here. So again, here's our ADK runner. That kind of is the runtime definition of our service. So we have our artifact service for in-memory artifacts such as objects. We have our session service for maintaining actual kind of chat session memory. We have in-memory memory, which we'll talk about later, for things such as like long-term memory or factual sentiments that we want to capture. But overall, this is our ADK runtimes definition, and we're adding plugins as part of that definition. So overall, now what we should see is the behavior of all our agents is that all agents will be affected by this cooldown plugin. So I'm going to go ahead and save that here and then zoom out. It looks like my screen froze, so I'm going to refresh, but let me make sure that I saved and then refresh now. And then now that we've defined our new ADK runner, let's go ahead and deploy our summoner to the cloud. But sorry, not deploy the summoner to the cloud. We're going to go ahead and rebuild all 3 agents. We want to make sure that they each have the, the plugin kind of in effect. So let's go ahead and do that now. And again, we're going to be using that same cloud build pipeline we talked about before. The image, the load to artifact registry, and then deploy cloud run. So let's go ahead and run that here.
Oh, is that because in the agent to A2A file, we're changing the plugin so that we have to redeploy because we're using this agent to A2A in all the agent file? Because now in order, I think we're using this agent to A2A to all the agent files so that we can have the remote agent, right? Because we're changing this.
Exactly. Yeah, that's a great point. Yeah. So even though we're working with remote agents, the ADK runner ensures that even when we're working with remote agents, they all have the same policies applied to them. So yeah. So again, this will take 2 to 3 minutes. And if you want to take a look at the cloud build logs, please just click the link, or you come over here to the cloud build search, and you should see that it's building. It takes a few minutes. Right now it's queued, but we'll wait and we'll come back. Okay, it looks like our build finished. So now what we should have is our 3 familiar agents have now been redeployed, but this time they all have the plugin effect kind of enacted for all 3 of the familiar agents.
Yeah.
So come over here to Cloud Run, and just to double check that it kind of redeployed as expected.
Yeah.
You go to Services. Again, you can kind of see that this was last updated 2 minutes ago. So that's a really good sign that these agents were updated as expected. And now we can actually go ahead and test our Summoner agent locally before we deploy the Summoner agent finally to Cloud Run as well.
Okay.
Over here to the lab, after we've deployed and built the new agents, let's go ahead and run ADK run Summoner so we can build up a terminal interface for interacting with the Summoner agent. So coming back over here, I'm going to say paste ADK run Summoner.
Oh, I don't see your terminal.
Thanks for letting me know. So, so it's going to take a few seconds for the exports to kind of come into effect, as mentioned before. And then we can go ahead and test our Summoner agent locally. And what we should expect to see is that whenever an agent gets delegated to, we just see the cooldown be enacted and checked. So, okay, let's go ahead and test it. So I'm going to say hype, and let's invoke hype again. And again, for hype, I believe it's fire that gets called. But overall, we should see the callback come into play. So we can see that let's zoom out.
Can you share the screen?
Thank you for letting me know. So what I just did was I called the same hype command that we ran in ADK Web before. And then I can see that, so hype is a single slow-moving target with thick armor weakness is an inescapable reality. Then I can see that a few things happened, and then the fire familiar was called. If I were to do the same thing, I should see the cooldown come into effect. The fire familiar is exhausted and must recover its power. So that's a really great sign. So again, we didn't define an individual callback, but we can see that the fact that we added it to the ADK runner itself is now affecting all agents within the runtime. We can do a quick other test to kind of confirm this and then move on.
Okay.
Say hype. Now I already did hype. Let's do a different one.
Okay.
I'm going to say, actually, we already tested it. So I think that's pretty much it. we confirmed that through fire familiarity.
Plugin works.
So it works. So there's no need for us to, if you want to do it, you can try to invoke water or earth, but it works. So again, that's a really great example of how plugins work with the ADK.
Yeah, so what we covered so far is we cover A2A agent-to-agent protocol, and then in the A2A we have runner, right? So we install this plugin on the runner so that all the remote agent can inject this logic in their life cycle. And then before every time they start, they will check, okay, whether it's still in the cooldown period. If it's not, then it will just go ahead and continue. The agent will start using the tool. If it's within the cooldown period, then it will pause, right? So that's how we are. So that's we cover the A2A, we cover callback, we cover how to install plugin one so that you don't have to copy paste the same callback for all the agents that need the similar logic.
Yeah.
Great. So what's next?
So let's move on to the final step of the lab before we get to the boss fight. So now we're going to be talking about agent state and memory. So we're now at part 8 of the lab. And what's the thing about what agent state and memory is? So Annie has some great labs about she's the memory guru. So Annie, can you please kind of, in your words, explain the difference between memory and state?
Hello.
And why it matters in context of an agent?
Yeah, sure. So agent memory is a very broader concept, right? But in this lab, in this scenario, when we talk about agent memory, it's the memory of our conversation, right? For example, if you're the agent, IO agent, I'm talking to you for the whole time, and then all the conversation it will store in the agent memory, right? And then the agent state is maybe I want to have some important information that I want to pass to another agent, or I want to remember. So I will have this dictionary with key value to it's a summary of our conversation. For example, we talk about coffee break. So we can say, at this time we have coffee break. That is a state we can store. And that state can pass from agent to tool and from agent to agent and also agent to agent and agent to tool.
Okay, right. It makes a lot of sense. So essentially, state is more concrete values. You're extracting specific details from the conversation and saving it as part of a scratch pad, like a dictionary. But memory is a little bit more semantic. It's more of conversational, nuances that aren't really key value pairs, or more just sentiments that are extracted by, for example, an LLM and then stored in something like vertex AI memory bank. Is that correct?
Yeah. You can essentially store either in memory. For example, that can store in the RAM, but every time you restart your server or you close your window, you lose all the conversation history. And you can also store in any type of database you like, for example, like Cloud SQL or more. Or you can store in Vortex AI, so that we have Vortex AI memory bank can have long-term memory, so that every time it will capture the summary of all the conversation stored in the memory bank on Vortex on the cloud. So every time we have conversation, it will always remember the previous context by retrieve memory from Vortex AI memory bank. So we have different type of solution for agent memory, and we can put the link of more reading here so that if folks are interested, you can take a look.
Yeah. Okay. Yeah. Absolutely. And great explanation. But diving back into the lab, so the reason why we talked about memory and state is that's what we're next going to do as part of this lab. So before we talk about callbacks as a way of injecting custom logic into the lifecycle of an agent. So before we created a before agent callback, and then we globalized it with a plugin. In this particular use case, what we're going to do is use an after tool callback. So not agent, but after tool callback. So whenever a tool gets called, we're going to remember the last familiar that was summoned. So remember, our summoner is summoning different familiars, earth, water, and fire, to kind of fight these different monsters. Before we call a monster, we actually want to remember or save the state what was last called. Whether it was a fire, was it water? So to do so, we're going to call that after tool callback to actually then interact with our state and then add new values to state. Sure.
Let's see how we are able to save that state and then put that in a specific callback.
Yeah. Absolutely. So where we're going to do that is go to the summoner agent.py file. And all we're going to do is add a quick local function that takes as input a tool context as well as a tool. And then essentially what it's going to one thing that you can do with callback context as well as tool context is interact with state. So through tool context, we're going to interact with state and save a new variable called last summon, and then save a familiar name that was called. So essentially we're going to prompt the summoner to extract or call this tool this callback with the name of the tool that was called, and then save it to state. Yeah.
Let's do it.
Yeah, so that's the function definition here, and that's agent.py. Come back over here to the editor. I'm going to go over here to open editor. Let's go to summoner.agent.py.
Don't forget to zoom in, Yael.
I'm going to zoom in here. And then save last summon after tool. Again, it's just a simple function definition. And then again, all we're doing is, this line is the most important part, using tool context to access state, and then add a new variable to state last summon. And we're saving the name.
Yeah, that state is a summary of, if you don't have the state, you have to pretty much go through all the conversation history and extract that important information. And with state, you just need to store things in a state so that, to have that to have that state in the context, and then so that you can communicate with agent to adding more custom logic. In this case, it's like we are having more. Yeah, we can have this logic in this callback.
Yep, exactly. And then lastly, similar to what we did before when we added a new callback for before agent, all we're going to do is go to the summoner agent definition and add a new parameter called after tool callback equals save last summon after tool. So down over here to the code. Yeah, so what are you going to say, Annie?
Yeah. So in this case, it's actually kind of interesting because, summoner agent, when it's like a hierarchical routing pattern, right? So we have this root agent, we have the sub agent. So when the root agent delegate to a sub agent, it's actually calling the tool like transfer to agent tool. So that's why here we're after it's delegate using that tool. So the root agent will use that tool to delegate to the sub agent, and then so it's after that the delegation, it will save this to the state. But that tool is not explicitly written here because it's implicit tool of this agent.
Makes sense. That's a really good point. Yeah. Okay, so what we've now done is add that parameter to the summoner agent definition. And then lastly, what we want to do again is we want to kind of instruct it on, how to leverage these sub-agents and tools that we've now given it. So you are the master summoner, a grand strategist who orchestrates your familiars. Your mission is to analyze the description of a monster and defeat it by summoning, and so on. And you can kind of read the rest of the description if you're interested. But that's pretty much it. So let's replace the entire agent prompt with that. And be very careful. I know a lot of you sometimes like to, change the quotes or anything, but you can leave these 3 quotes at the beginning and end and just change what's inside the middle. So I'm going to go ahead and do that here. And okay, and we're good to go. So master summoner, we have a new prompt for our summoner, and that's it. And coming back over here to the share tab, we now want to run it locally and make sure that everything's working. So let's go ahead and do that. So overall, let's think about what should happen now. When we're working with the agent, what we should see happen is that, again, cooldowns come to effect, as well as we are saving to state the last called familiar. So I'm going to go ahead and copy this, and let's see.
Let's see if it's remember what is the last familiar.
Yeah. So again, if you haven't used your terminal for some time, you may see this message.
I don't see a terminal, Io.
Thanks for letting me know. So again, if you haven't used your terminal for some time, you may see this message: your connection to Google Cloud was lost. Just click the reconnect button in the top right corner of the terminal. And then I'm going to zoom in so you can see. And I'm going to go ahead and run this here, the ADK run summoner that I mentioned before.
Yeah. Yay, this is user. You can input your prompt.
Yeah. So I'm going to go ahead and I accidentally clicked the button, but okay. Okay, hype again. And this is really good for us to see again. So even though I said reconnect, because I hadn't used the terminal for some time, I'm seeing this message, which essentially means that I have to re-authenticate in the terminal. And the best way to do that is just to refresh the browser.
Yeah.
So I refresh the browser, and I'm going to go ahead and do ADK run summoner one more time. So I'm going to go ahead and copy that command and run it.
All right. So I can see it is running. Let's quickly test it, Io.
Okay, let's test it. Okay, so I'm going to go ahead and put hype as a single slow-moving target with thick armor. And let's see what happened behind the scenes. Okay, we can see that saving last summon familiar transfer to agent. So that's the function that Annie was mentioning. And then we can actually see that it saved the state. Again, what we told it to save, agent name, fire familiar. So it called.
Maybe you want to zoom in a little bit.
Sure. So it called fire familiar, and then it actually saved the state, this new value as part of the state dictionary. It's kind of hard to read here. With ADK Web, it would be slightly easier, but overall, this works all the same. So overall, you can see that it's working. So now we're saving things to our short-term memory scratchboard. And that's great. Okay, that was the last step of the lab. So now that we've tested our summoner, it's working locally. We're going to deploy the summoner to the cloud and then do a boss fight in the cloud. Isn't that exciting, Annie?
Yay!
Excited, Annie. Okay.
Boss fight, please deploy.
Okay, so let's go ahead and deploy and get this started. Okay, so again, as you know now, with cloud build deploy, it takes a few seconds or a few minutes, but all we're going to do now is deploy our summoner agent to the cloud and then engage with the boss fight. And remember, our summoner agent is an A2A compatible agent. The dungeon or the boss is an A2A compatible agent. So really behind the scenes is all A2A facilitating this interaction and this fight. But we'll see that in a few minutes. Okay, it looks like our agent finished deploying. If we want to double check this, we can go over here to Cloud Run. I just happen to be in the Cloud Run area already. And I can see that we have a new summoner agent that's been deployed. So we have our 3 familiar agents as well as a summoner agent that's been deployed. And you see that this happened just now. So everything is looking great. So that's all looking great. So we deployed our orchestrator agent. We deployed our familiar agents. And now
is that time to fight the boss?
Boss fight. Okay, so let's get started with that.
I can't wait. I really want to see. Exciting.
So coming over here to the boss fight, which is the last step before cleanup of the lab. And regarding cleanup, please feel free to do that at the end if you want to, or if you want to build on some of these architectures and continue, please feel free to. But again, going back to the boss fight, what we want to do is echo our summoner agent path as well as the dungeon path. So let's go ahead and do that. And
don't see your terminal.
Oh, thanks for letting me know. So here is the summoner agent path, and we'll do the same thing for the dungeon agent path. You don't necessarily have to do this. You can just go directly to the URLs in the Cloud Run dashboard, but this is a quick way of doing it. And what you want to do once you do this is click the agent versus dungeon. When you click it, a new UI will be brought up.
Oh, so this is the battleground for us to fight the boss.
Exactly. Yes, and what you want to do is click Crimson Creep, and then enter the dungeon. So let's go ahead and do that now. And I'm going to come over here and copy the summoner URL now. So copying summoner, come over here to the dungeon, and put the A2A endpoint, which is essentially the path of our summoner agent, and it automatically classifies it as summoner and dogma. So again, we just want to put the base URL. Don't worry about putting well-known path. All that is automatically handled for you. And then enter, and our fight begins. Start fight.
Wow.
Blindly follow the linter is salvation. We're fighting dogma. There's only one true framework, and it is the only one we've always used. That's pretty dogmatic.
I saw this is currently using the fire familiar, or is always using the fire familiar?
Oh, no. So for dogma, that's a great question. I think for dogma, it may choose one familiar more frequently than others, but I think it will still kind of decide which one makes the most sense.
Okay.
You will conform to the established architecture. Deviation is heresy. That's not how we do things here. So essentially, the boss fight is going to kind of give some dogmatic sayings, but then you should see some question and answer come up pretty quickly. And that's essentially how you submit your answer. And then that gets translated to an A2A communication that essentially has hit points, as we discussed before. And that's your boss fight. But it does take a few seconds. So we'll wait for Dogma to kind of stop talking. You know, all villains have a master speech, you know. Okay, it looks like our Dogma finished its master speech. And as mentioned before, here's our Q&A questions that we can answer. So in the workshop, why are the tools like the elemental fonts built as separate services? So to make sure all tools are in the same programming language, to make the project more complicated, so you can update a tool without having to change the main agent, to stop agents from using any tools. I always like the longest answer, so I think I'm going to go to, what do you think?
Yeah, maybe.
Oh, yeah, it worked. 270.
I mean, you explain why.
Okay. So we deployed our tools separately. If you recall, our MCP servers separate from our agent definitions. And it's a good practice because you may want to update the tools without having to update the agents. So it's a really good kind of separation of principles. Yeah.
Cool. And let's see, what is the next question?
And again, Dogma always likes to talk. Doubt is a poison. A new library is a poison. You can imagine. So again, we'll wait for Dogma to finish his little speech. Okay, so time for the second question. What is the ADK web command used for?
Maybe your longest answer.
To check
longest one.
Longest one? Okay. To start a local test server with a user interface in your browser.
Yes.
I think that's correct.
Yay. We did that quite often.
Okay.
We also have ADK run, right?
Oh yeah, ADK run, but remember ADK run is for the terminal interface. Okay.
Yeah.
144 points left to go. I think we can one more hit and we're good to go.
But our health is yellow.
I know. It looks like the Dogma is kind of boring us to sleep. Okay, so one more hit and then we'll be good to go. The workshop uses a tool YAML file to create the database tools. Why is this a good approach?
Yeah, why is it a good approach?
It makes the tools run slower but more securely. It's the only way to connect to a database. Now, we learned other ways as well. It's an easy way to define database tools without writing a lot of custom services.
Yeah, let's choose it quick. We are almost
okay.
Okay,
we won. Victorious against Dogma. Okay, that was super fun. So let's kind of recap, Annie, what we built so far.
So a quick recap from part 1 to part 2. Like part 1, we talk about different type of MCP server, right? So the last question, we have this 2.yaml file that's actually from MCP toolbox. So we talk about how to use ADK to build custom MCP, and also we talk about how to using MCP toolbox to build MCP. And then we connect the tool to ADK workflow agent. So that's including parallel agent, loop agent, and sequential agent. And once we connect the tool to the agent, we will orchestrate them together in the hierarchical pattern, but we're connecting them through, we will first deploy them to remote agent and then connect them through agent-to-agent protocol. So that's what we covered last time, yesterday. And for today's session, we cover everything, agent-to-agent protocol, agent communication, and also cover, for example, what is a callback, how to intercept certain logic for the all agent lifecycle. And then we also talk about the agent memory, what does agent memory mean, and why we're having the state, how does agent communicate to through state. And so eventually, this is just like IO showing on the screen that we cover the whole picture from bottom, different type of server, MCP server for the tooling ecosystem. And then in the middle part, we cover a domain workflow with agent part. And then at the very top, we orchestrate everything. So I hope that you inspire from this to build your own multi-agent system. And you can learn how to build your own tool, how to orchestrate everything, how to design your own agent design pattern, and how to connect them and leverage agent leverage custom logic in callback and using agent memory and more. I hope you enjoy the session, and we're gonna cover more in next weekend. Thank you so much for those of you who tuned in today.
Thank you so much. Also, if you have any questions, leave it again comments in the chat. We're gonna answer all your questions and may even feature them next week as well. But until then, I'm Ayo.
I'm Annie.
And thank you. See you. Bye.
See you next week. Bye.